All right, as mentioned, we're going to start part 3 of the book today. We will go over the test on Monday. I have not looked at any of them, so I will tell you on Monday, we have to adjust something or whatever. All right, we'll see then. But section 3, which starts on page 411, is on, as you can see, ASP.NET database programming. There are 7 chapters in this section. It's around 200 pages or so. We're going to start by going over chapter 12, which, as it says, introduces you, or I should say reintroduces you, to the concepts and terms you need to know for developing database applications. Then in chapter 13, we go over data sources and the data list control to get data from a database. So when we first start doing this, you'll have to write little to no code. All right, but again, as you go on and you want to customize, of course, then you'll have to write more code. Chapter 14 uses a grid view. In many ways, using a grid view is like using a spreadsheet or like using a table. In fact, you can even put borders on it, so we'll do that. Chapter 15, we go through the details view and the form view controls. Chapter 16, we go through the list view and the data pager controls. Chapter 17, we go through 3-layer database applications, which is more code. And chapter 18, we talk about the entity framework. As you'd probably guess, the chapters, each one gets a little bit more complex than the previous one was. So you may or may not remember a lot of this stuff from last spring, all right? But in this an introduction to database programming, you've had virtually everything that's in here, all right? Now, I will tell you that it will be a little bit different doing this stuff in ASP.NET versus the way we did it previously, because we were using MySQL, a free open source database, relational database management system. Now we're going to be using SQL Server. Just so you know, it is possible to use MySQL with ASP.NET, or you can use Oracle with ASP.NET, or you can even use spreadsheets or whatever. All right. So, page 413, again, I don't want to read to you, but if we look at what's in here, an introduction to relational databases, how to use and how to work with them, how to work with other objects. What is new in this chapter is what you see in blue on the screen, and that's an introduction to ADO.NET. ADO is an acronym, and it stands for ActiveX Data Objects. The way that it used to work here years ago, when .NET kind of first became in vogue, I don't even know if they had C#, but they had Visual Basic, and they wrote Visual Basic.NET. And when you did that, it wasn't nearly as sophisticated as it is right now. What you had was you had a toolbox that ran along the side, kind of like you have in here in ASP.NET and what we had in C# when we did the GUI apps. But there were about 20 tools, and that was it. That was all you had to do everything. You're like, well, what if you needed to do more? The answer is you could do more, but then you had to go out to the internet and you had to download additional controls. The reason I'm telling you that is those additional controls were basically known as ActiveX controls. That's where the A and the ADO in here, that's where it comes from. All right? So we will talk about how the basic ADO.NET components work, about concurrency, which you may or may not have heard of before, about the fact that by default this uses what's called a disconnected data architecture, and finally, we'll talk about how to work with data without using an adapter. All right. I don't think you need the history. If you do, look up EFCOD. EFCOD is kind of the father of relational databases. All right. Remember that when you're working with this stuff, it's basically like a spreadsheet. It's a two-dimensional matrix that consists of rows that go across, columns that go up and down. Rows are called rows. Sometimes they're called records. Sometimes they're called tuples, T-U-P-L-E-S. All right. Columns are called attributes. They're also known as fields. It just depends on the book you read. And unfortunately or unfortunately, some books just go back and forth between calling them, different terms. All right. It says in this book, we've used the words rows and columns for consistency. And you may or may not remember this, but this is something when we first started talking about databases, I kind of put something on the board or whatever that looked more or less like this. Blow this up a bit. I said, it's not big enough. I said to you something along the lines of, what is going on here? There we go. I said, what's a character? All right. And basically, we're talking about any keyboard character. So that's anything you see on your keyboard, including special characters, including numbers, including digits, including the space bar, everything you can think of. So we'll say here, any keyboard character. All right. And then we went up to a field, and that's one or more related characters. All right. So we're moving up, in other words. So what do you mean one character? Well, if you had a field that was just called middle initial, or MI, it could be as small as one character. Most fields are more than one character, but it's totally within the realm of possibility that any field could be just one character. All right. Then you go up to a field, or a record rather. A record is one or more related fields. Well, this summer, when people were starting to sign up and I was getting new first-year students, for a while, I had just one. Then I had two, and then it went up. So for a while, my record, literally, I had one record, right? That was it. Now, there were many fields in it, but I had only one record. So a table is one or more related records. All right. And then finally, a database is one or more related tables. Now you should be able to understand all that stuff after what we went over last semester. There shouldn't be any surprises in there. All right. We will be working mostly with the Halloween Superstore database. We're going to take a good look at that in just a few minutes because that's shown in the book. And they really do break it down. Now, there's other terms that you have to be aware of. But is there anything that's on the board right there or on the overhead, that you don't get? Okay. So you should be able to go in and look at a database and identify and say, okay, how many tables are in this database? For each table, how many records are there per table? For each record, how many fields are there? I mean, you don't typically break it down to a character level, but we will talk about that too. Okay? In addition to this stuff, and let me just get rid of the blank lines here. Whoops. So in addition to this stuff, a couple more things that you should know. A primary key. A primary key is a unique record identifier. Back in the day, back in the 70s, back in the 80s, back in the 90s, when they were making primary keys, almost always, if it was for a person, it would be your social security number. Now, that's still how you're tracked today. You've got to rank a number, but don't think that somehow they aren't doing something based off of your social security number. I don't know for sure, but I'd be amazed if they were not. All right? But quite often, more often than not today, a primary key, I'm gonna erase the word after I put it in here, but a primary key is supposed to be unintelligible. And what that means is if somebody gets the primary key, they shouldn't be able to do anything special with it. All right? In other words, that's one of the reasons that Social Security number is not a good primary key. Because if somebody gets your Social Security number, you could be in a lot of trouble because of stuff they do. I don't mean that because of something you did, but if you've ever seen those commercials on TV, that's why companies like LifeLock exist. All right? So a primary key is a unique record identifier, and many times the primary key is going to be a field called ID. If you remember that from last semester, it'll be an integer field that you just automatically increment. You may remember last semester when we talked about MySQL, we set up fields, we set up our primary key most of the time as auto increment. Remember that? Okay, it's not done exactly the same in SQL Server. I'll show you what the difference is, but they call it an identity field instead of auto increment. And you just have to, you do it once or twice, you're like, oh, it's different, it's stupid, I like the old way, or whatever. Okay? So, a primary key is a unique record identifier. How about a foreign key? This will have to go over a couple lines. It's typically used in what's referred to as a one-to-many relationship. Now, we've talked about this before, but I do want to say it. So imagine I have two tables, all right? I have table 1 and I have table 2. And I should come up with better names, but I'm going to say I've got field 1, field 2, and field 3 here, and this is the primary key. All right, and here I've got field 4, field 5, and field 6. And this is the primary key, all right? Right now, the way that this is set up, there is no relationship between these two. So say, for example, this was products, okay? So let's just say that this was products. And this was categories. Because we actually have that for the Halloween Superstore, all right? So the way that this list would be set up is every category would have 0 or more products. Does that make sense? All right. So this would be what's called the one side. This would be what's called the many side. Now this goes by a lot of names. Sometimes it's parent-child. All right. It used to be called master-slave, which is a derogatory term. It's not used anymore. But some books, older books, you still see stuff like that in there. All right. But it's basically one to many. That means for every one record in here, there are 0, 1, or more here. If I work at the Halloween Superstore and I got a new category, I just created it today. I decided we're going to sell drinks. I mean, it would be stupid, but you get the idea. And I don't have a drink yet. Then there's 0 records over here. That's still viable. So every one that's over here results in 0, 1, or more that are here. And the way that I can relate these tables together is I've got two primary keys, but I take that F1 and I put it in here as another field. Now I'm able to do a join because I've got a common field between the two tables. Hopefully you remember that from last year, all right? Because that's the kind of stuff, again, that we're going to do. Because back in the olden days, you know, pre-1970s and even the 70s, you worked with what was called a flat file. Sometimes they call them flat file databases, but that's sort of a misnomer, all right? What's the thing about a flat file? There was only one table, okay? And you see, I never heard of anything like that. You kind of saw that when we were at the St. Charles County, because that's kind of the way she writes things, all right? I asked Charles when we came back, I said, now, I said, I'm going to say a few things, and I don't mean it all to sound derogatory. And he looked at me funny. I think he thought I was going to talk about him, and I wasn't. I said, is it just me, or did she seem to be totally self-taught on databases and really didn't know very much? He said, no, it wasn't you. You know. And the thing is, I think that's the thing, is they had no one there who knew databases. So she agreed to take that on, and I give her credit for doing that. I'm sure she got books, went online, did something, and did what she thought was the best type of job she could do. I'm sure she did. But that said, much of her stuff is almost like a flat file, because you'd have tables that would have 50, 60, 100 fields in them. Doesn't make much sense. You didn't even think of joining stuff together. You got another field? Oh, throw it into that table. All right? And that's just not the way that things should be done. Now, there are a few more as we go on. I'll come back to this. But my question is, with what we went over so far, any questions on any of these terms? Sooner or later, we are going to be developing our own database. All right, if for nothing else, we'll make some kind of a database for this loan application that we've been working on. I'm not sure what it'll be. All right, I'm not worried about it. We'll come up with something. All right. So they also mention here, you know, they start talking about some terminology. Rows and columns, we talked about, records and fields, etc. Primary key, we've talked about it already. Sometimes, not that often, but sometimes you have to take and combine two fields together to make a primary key. So let's say that I had a primary key and field 1 wasn't enough. It had to be field 1 and field 2. You understand? If you have to do that, if a primary key consists of more than one field, I'm not going to write that down. It's called either a composite primary key or a combined primary key or basically it's one of those, or a concatenated primary key. Okay? So one of the C words. All right. In addition, you can have what's called not a primary key, but a unique key. So let's suppose that I create a table, okay? And let's say that I knew nothing about I know nothing at all about databases, not a darn thing. And what I have in here, I'm not going to worry about having two tables. I've just got one right now, okay? And I've got in here social security number. Let's say they've got an employee number, a first name, a middle initial, a last name, an address, a city, a state, and a zip. We'll just leave it right there, okay? Now, I could come in here and make something here where I would call this ID. I could do that, and that's probably what I should do. But let's say I don't even know about that. And now I say, you know what? I don't know which of these fields, right there, social security number or employee number, they're both unique. I don't know which one I should make as a primary key. All right? So I decide, you know what? I'm going to use employee number. So that's going to be my primary key. But I also want to set it up so you can't put the same social security number in more than once. Does that make sense? It's not a primary key. That's called a unique key. So that still says that they have to be unique, but it's not a primary key. And sometimes you want to do that because you want to make sure that whatever value you have for that one is never replicated. And again, if it still confused you, they mention it right there. It's in the book. Unique key. I'm giving you my take on it. It's not going to be exactly the same as it is in the book. All right? So let's say right now, I looked at Amin, I said, Amin, what's a unique key? And he's like, I don't know. And he's not sure, he doesn't have his book open or whatever. He might turn to the back of the book and look up unique key, right? Finds out that it's on page 414. So he looks there, scours through it. Yeah, I can tell him what it is. All right? What has he done? He's just gone through the index, correct? To find something? Well, what you can do when you're working with databases is you can create indexes. All right? And when you index something, you make it easier for the relational database management system to find. All right? Just the same way common terms are put in the index of a book. Now, there's more to it than that. If you are constantly running queries on certain fields all the time, you're typically going to add indexes to those fields because it'll make your queries run faster. Okay? So there's a lot of different criteria for how to index. You can also have indexes on more than one field. So if I was constantly doing, let's just say that, where Ms. Zika was, it sounds like a lot of the work that she does, she's getting either business information or information about people. In one of her databases, she could very well create an index on first name plus middle initial plus last name. That way, if she had to query on that stuff, she could get it real fast. All right? So, indexes provide an efficient way to access the rows in a table based on values in one or more columns. All right? So, this is the products table in the Halloween database. You could tell I'm not asking you this. You're all smart enough that I could tell you to ask you to count. You could tell me how many fields were in here. I could ask you to count down, and if this was the whole table, you could tell me how many records were in there, correct? All right. Then the next thing you have to think about is, okay, with the stuff that's in here, what types of data is it going to be, for lack of better words? And I'm looking at this. We don't have exactly a string. Typically it's text or it's char or varchar, if you remember that from last semester. But character field, character field, character field, character field, character field, character field. This one, decimal or double or float or something like that because it could have a decimal place, right? This one, whole number. Those are the kind of things that have to just stick in your mind because if Ms. Zika asks us to rewrite a lot of her stuff, all right, you should know, for example, if they said, how many years have they been a member here at the St. Charles County Economic Development Center? I mean, you should look at that and go, that's going to be a whole number field. We're not going to sit there and say you've been a member for 3 years, 8 months, 2 weeks, and a day. We're not going to do stuff like that. All right? So it's going to be a whole number. If we say how much money is the company worth, it's going to be either a currency field or a field that has a decimal place in it. Those are the kind of things they have to stick in your mind, and they just have to make sense to you. So you can look at the stuff that's in here. This is on the bottom of page 415. I'm not going to read it to you, but it's more a rehash of the information I just gave you. All right? I do want to mention something because I kind of passed over it, and the author's right with what he says, but it never happens. So he says here, the only difference between a unique key and a primary key is a unique key can contain a null value and a primary key can't. Remember, null is unknown. It's the equivalent of blank. But can a unique key be null? The answer is yes. But how many records can have a unique key of null? One. Because as soon as you have two records that have a key of null, it's not unique anymore. So that's what they say is true, but that's not. It says the only difference. No. The difference is, with a primary key, it's a unique record identifier. It's something that you picked to uniquely identify each record. With a unique key, it could be something that you picked, but you didn't. All right, that's the big difference between them. All right, so again, more stuff on here. The other thing to remember too, and hopefully you do remember this, we talked about it a little bit last semester. And we're going to get into this. I'm jumping ahead a little bit. These are the three different kinds of relationships you can have. You can have a one-to-one, you can have a one-to-many, and you can have a many-to-many. These are the three types of relationships. This is the one in the middle, you want to shoot for. All right? Let's assume for a second, because it'll be easier to show it to you. So let's say that I'm going to make a table, and I'm going to call this person. Kind of a dumb name, but I'm going to call it person. And I'm going to have social security number, first name, last name, middle initial. Oh, we won't even put a middle initial in there. Address, city, state, zip, home phone, even though a lot of people don't have one anymore, cell phone, email address, secondary email address, all right, etc. So I keep doing this. And pretty soon, without realizing it, I've got 30 fields in here. There are not 30 there, but you get the idea. I just keep adding stuff and adding stuff and adding stuff. And then I say, oh, and you know what else I need to put in there? I need to put in their work information. So I need to put on, what plant number they work at, what shift they work, who's their supervisor, etc. So now I'm up to 40 fields. And it's like, this is ridiculous. So what I do is I grab all of the information, all of their work information, okay? So in their work information, I move all that stuff. So now I've got the plant they work at, I've got the shift that they work at, I've got their supervisor information, and I add their social security number in there as a primary key also, so I can link them together. See what I'm saying? So when you've got a one-to-one relationship, you've got a table typically that's so big you break it up into two tables. You don't have to do that. And you can I could take this and make it into one table. You typically break it into two tables because it's easier for people to fathom. I don't know if you've ever heard this before. Maybe I've even said it to you. I don't know. When you are presenting, so if I'm up here and you're business people and I'm presenting to you, I'm sure, like I said, Ms. Zika probably does her share of that. There's something called the rule of sevens. And with the rule of sevens, it says, let's say this was a PowerPoint presentation. I shouldn't have any more than 7 different concepts on the same page. Because if you do, people start going nutty. It's too much for them to comprehend. 7 is actually too many, all right, on a PowerPoint slide, but you shouldn't have any more than that. Well, in the same way here, you get to a certain point where, I can keep putting stuff into this table, but this table is so huge, I'm breaking it up into 2 tables. So there is a one-to-one relationship. What that means is it could just be one table, but I broke it up into more than one for easeability and readability. That's one-to-one. Occasionally you may feel the need to do that. All right? With a one-to-many, for every one of these, there is 0, 1, or more of these. So a good example of this would be if I had employees and I had departments. This would be the one side, this would be the many side. That would say that every one department would have 0, 1, or more employees working for them. Does that make sense? That's a one-to-many relationship. That's what you always shoot for. That's called the nirvana, basically, of database relationships. Sometimes you've got 2 tables, and it's kind of what I showed you before. So let's assume for a second we've got employees, and here we have plants. I don't know. No, plant would be a good one. I'm trying to think of something that would make sense here. All right, I'm just going to call it X. And we've got a bunch of fields here. Again, I'll just put them in as F1, F2, F3, F4, and F5. This is X1, X2, X3, X4. There is absolutely nothing in common between these two tables. Nothing. And it would make no sense to take one of these fields and put them over here, or one of these fields and put them over to here. Does that make sense? There's nothing that makes sense to do that. So you create a new table. You come in here and you create a brand new table, and quite often you're going to call it X underscore employees. And if this is the primary key, and if this is the primary key, it's going to have two fields in it, F1 and X1. And they will be one of these concatenated primary keys. So the only reason for that table existing is so that you can combine these two tables together. That's a many-to-many relationship. The reason I'm telling you that is relational database management systems aren't designed to handle many-to-many relationships. They can't handle this by itself. That's why you need to do this. This other table that you create is typically called a join table, or a juncture table, sometimes it's called, or it's even called a jump table. All right? Does all that make sense? Any questions on any of that? All right. Again, this is all stuff that will have to, for lack of better words, just make sense to you. It's got to click for you to be able to do this stuff and understand what you're doing. Okay? It's not impossible, because I don't know if you'd call this thinking outside of the box. You may end up, for one of your next tests, whether it's going to be on the loan app or something else, I might give you a bunch of fields and a bunch of stuff and tell you to create a table structure based off of that, one or more tables. All right? And I will tell you, if you don't know this, this is not a joke either. Nationally, the average for a database person, a database professional, okay, and it's typically somebody with some experience. So I don't mean you're going to jump out of here and get this job tomorrow. It's $92,000 a year, all right, across the United States. That is the average. That's one of the higher paying IT jobs on average in the U.S. All right. So how tables are related. We just talked about this. There's the one-to-one, okay? So they're showing you here, well, they don't really show you a one-to-one, but I did, all right? One-to-many relationship. We talked about that already too, and we've talked about many-to-many, all right? So again, we already looked at this. We looked at the foreign key, the example. So you've seen this. This is the picture that's in your book on page 417. This should make sense. You should have an understanding of why category ID was added to the products table. And that's so that you were able to join together. So if Amin's my boss and he says to me, I need a report, I need the long name of every product we have, plus I need the unit price, and I need the number on hand. Okay? So what he needs is this field, and this field, and this field. If we didn't have a field in common between those two tables, we couldn't join them together to get that information. And if there were hundreds or thousands of products, I wouldn't want to be doing that by hand. It sounds like that's some of what she does right now. Because they have such a poorly set up structure, a lot of stuff is being done by hand right now. All right? So this field, and when you add this field, this foreign key, it's the primary key of the one table is added as a field into the many table. That's what you have to realize. So every category has 0, 1, or more products. You wouldn't want to do it the other way. You wouldn't want to take product ID and add it to this table. So you want to take the primary key of the one side, the dominant side, and add it as a field to the many side. Does that make sense?
One-to-one doesn't make a difference.
No. One-to-one, you're going to have the same primary key typically in both tables. All right? All right, so they explain that here. Again, if you need more, they talk about primary key, they talk about foreign key, they talk about one-to-one, one-to-many, etc. All right, so how columns in a table then are defined. Now this is a little different the way that it's done in SQL Server as opposed to the way that we did it or didn't do it, all right, in MySQL. If you look on the screen here, it says with SQL you can choose from system data types like the ones in the figure. We'll look at that in just a minute. What you can also do is you can store nulls, not store nulls, but say something is null. You can set default values to a column. We've talked about that kind of thing before, that if we're doing if we're setting up a table for Rankin Technical College, we might want to set the state up. You know, we're asking a person information. We might want to set their default state to Missouri. Okay, that kind of thing. That's just an example. It's not the only type. You can default anything. If it turned out that the unit price that we looked at before, if you know, you ever gone or you've seen those Family Dollars or everything as a dollar type of stores, if it turns out that literally 99% of my stuff in the store is $1, I'm going to set the unit price. I'm going to default it to $1. And then just change the ones I have to change. All right? Okay, again, as I mentioned before, what we did before was auto increment. What we'll do now is we'll create what's called an identity column. And it looks like it's a lot more work. Once you've done it once, no, it's not. You're clicking a couple selections. That's it. It's not that it's difficult at all to do it. Really and truly isn't. Another thing that you can do in here, and I believe, at least in my opinion, for whatever that is worth, you can set up check constraints. So for instance, let's assume that we've got a field that's called price. And you know, for whatever our product is, the price has to be something between 1 cent and $100. Does that make sense? So the minimum would be a penny. The maximum would be $100. I can set a check constraint on the actual field itself that says the value that goes in there must be between 0.01, a penny, and 100.00. So if somebody tries to put in 0, it won't take it. If they try to put in $101, it won't take it. That's a check constraint. That's not that different from what we did with our range validator, is it? We put in minimum and maximum values. So you already know how that works. All right, but now we're talking about confining the data. Okay, so if you look here, this is page 419 in the book. When we come in and we start setting up our tables, they're going to look like this. Each one will have a name. Each one will have a data type. They will have a checkbox, and if the allow nulls is checked, you can leave it blank. All right? So, for instance, with that image file, it might be a brand new product, or you know, we don't have a picture of it yet. So we're not requiring that there be an image file. So if you notice, you can see where it says image file, the allow nulls is checked. We can have a default. And we can come in for any of these, and we can set primary key, we can set check constraints, we can set indexes, we can set foreign keys, and what we'll talk about later on, much later on, is triggers. All right? Now, what they're saying here is these are common SQL Server data types. Please look at either your book or on the screen right now, because this is more, again, stuff that should make sense to you. Bit. 1 is true, 0 is false. Sounds a lot like a Boolean to me. But if you look in here, there isn't a type under common SQL Server types that say Boolean. So you replace Boolean with a bit type. Does that make sense? All right. Char, varchar, nchar, and nvarchar. There's virtually no difference between a char and an nchar, between a varchar and an nvarchar. But a field that has just char in it, char or nchar, means it's fixed length. So if I was going to create a field that was called state, and I wanted it to be a 2-letter abbreviation, I would make it a char or an nchar. If I was going to make a field called state, and I wanted to write the name of the state, all right, I could come up with the biggest one. What is probably Mississippi? All right, probably has the most letters in it. Let's say, I don't know what it is. I don't care. Let's say it's 14. Then I could make it a fixed length of 14, but then a smaller state would be wasting a lot of resources that it didn't have to. All right, so char and nchar are fixed length. Varchar and nvarchar are variable length. That's what the V stands for, is variable. All right, and notice that a char, an nchar, a varchar, or an nvarchar can hold anything. If I put in there an address and I make it a varchar field and I put in 755 Par Road, and let's say all I put in there is the 755. Are you with me? So I've got a field called address and all I put in is 755. That's not the number 755. If it is a char or a varchar, that's a string. So it has no numerical value to it whatsoever. All right. Dates. There's a lot of different ways that you can set up dates. Notice again, alphanumeric that represents a date. All right. Decimal and numeric. Numeric data accurate to the least significant digit. If you are working for NASA, you're not going to be using type decimal. All right, because you might have to be within a trillionth or a quadrillionth or something of a decimal place. All right. Floats and reals, pretty much we know what those are already. Big int, small int, and tiny int. A big int is like a long that you have in some languages. So if I wanted to be able to represent the national debt, and I want it to be a whole number. In other words, if it's a quadrillion, $53.12, no. You know what, if it's a quadrillion, $53.12, and somebody gives me a check for a quadrillion and $53, I'll forget about the 12 cents. All right? So those are whole numbers, but they can be either very big or very small. Okay? And then there's money and small money. That's like currency. Okay? So as mentioned on the bottom of the slide here, the data type that's assigned to the column determines the type of information that can be stored in the column. The reason that this is important is eventually we're going to be wanting to take what's in the database and we're going to want to be able to manipulate it using C#. Does that make sense to everyone? When we do that, C# doesn't have a variable type called bit, as an example. So you have to know the equivalent of C# in SQL Server or vice versa. Okay. Again, the null is the absence of a value. It's not zero, it's unknown. Ethan, what's your GPA? I don't know. Then the value would be null. I don't think there's in fact, I know there's not a person in this room. You wouldn't be in the second year of the program if you didn't pass the 2 classes in the first year. All right? But right now, when they had their thing in here, their little thing at the beginning of the semester on clubs, the people who were first year people couldn't join, and I think some of you are members of the Phi Theta Kappa. You couldn't join. Why? Why couldn't they join? They don't have a GPA. It's not that they don't have the minimum, they don't have a GPA yet. So they can't join it because you need, 3.5 or 3.7, whatever it is. All right, so technically their value is null. All right, we talked a little bit about the identity column. You're going to see that. We talked a little bit about the check constraints. You're going to see that. All right, maybe the most important part of the chapter. So let's go over this and then we'll take a break. The design of the, of the Halloween database. And let's just go right to it. Should be able to blow it up a tad. No, that's too much. All right, that should be big enough, hopefully, that everyone can see it. When you see this symbol, if you look right on the screen here, see this symbol? You see it in several places there. The one that's right here looks kind of like an 8 turned sideways. Some people call that the infinity symbol. That's the many side of a one-to-many relationship. All right? Sometimes instead of seeing it like this, just so you know, sometimes what you'll see in here is when it's drawn like this side will look like this. And it's called a crow's foot, because that's what it's meant to look like. And that'll symbolize the many side. And the only reason I'm telling you that is there are a lot of books out there that do that, instead of putting in like our author did. All right? So you can see every one of these databases, every one, I think you'd agree with this, every one of these databases has a primary key. All right? It's symbolized in here by the key, and sometimes it's more than one field. But every table has got at least one field that represents the primary key. Not only that, there is not one table in this structure that's in an island. In other words, there's not one table that's over here that we create that's not connected to anything else. You can't have that. Now, you're all smart enough to know that if for some reason, and this, what I'm about to tell you makes no sense, but let's just suppose we have the manager from hell. And the manager from hell wants something with unit price and quantity, but they also want, let's say, I don't know, zip code. I know that doesn't even probably make sense, but you get the idea. Well, these two tables are not connected. So if I do a join, I can't join these two. I've got to join this one with this one and this one with this one. You have to do that. All right? If it turns out that I am doing a lot of that, then I might want to consider, is there an actual relationship between those two tables? And if there is, then maybe putting a foreign key, all right, from the one side into the many side table. But if you look at this, you should be able to figure out, okay, every customer, every state has 0 or more customers. Every customer has 0 or more invoices. Every invoice has 0 or more line items. All right? Every product basically will be made up of 0 or more line items. And every category has 0 or more products. That should make sense to you. That's pretty much what you get from looking at the picture right here. All right? Somebody took the time to develop this. And that's what's explained. Again, I'm not going to read this to you, but that's what's explained there. All right, let's take a break. It's 1:27. Let's come back at about 1:45, and we'll pick it up on page 422, how to use SQL to work with the data in a relational database.